Hi, welcome to Backer Breaks It Down. We continue to talk about dilations in this episode, but we're going to focus on dilations on the coordinate plane. So, you may recall, in a dilation, the image and the preimage are similar because they have the same shape but are different sizes. Corresponding sides are proportional, and corresponding angles are congruent. When we perform a dilation, we start with our center of dilation. Okay. The scale factor is the ratio of any corresponding linear measurements of the image and the preimage. And we simply divide image by preimage to find that scale factor. Okay. So since we're going to take these dilations onto the coordinate plane, let's investigate. The graph below represents a dilation from center 0, 0 by a scale factor of 2. Compare the preimage AB to the image A prime B prime. What effect does the dilation have on the coordinates of the dilated points? So A was originally at 3, 2. Then we performed that dilation and it became A prime, which is at 6, 4. Now we know the scale factor is 2. So what role did that 2 play? That's right. They took the coordinates of A, multiplied each one by 2 to get the coordinates of A prime. So 2 times 3 is 6. 2 times 2 is 4. So the image of a point A, comma B after a dilation with center at the origin and scale factor K has the coordinates of K times A, which is the X coordinate, and K times B, the Y coordinate. Apply the dilation to the polygon with the given vertices. Name the coordinates of the image points. Describe the dilation, center, scale factor, enlargement, or reduction. In both of these, the center of dilation is going to be the origin. When it comes to center of dilation not at the origin, well, that's what we get to do in the next episode. Woohoo! The scale factor is given to us in the rule for the dilation. So like here, that's telling us the scale factor is 2. And we know that when the scale factor is greater than 1, that makes it an enlargement. In number 4, that 2/3 is your scale factor, which means we're going to have a reduction. Okay. So what we just discovered is that you can simply multiply the coordinates of the preimage by the scale factor to get the coordinates of the image. So like in number 3, A is at 2, 1. So if I simply multiply both of those by 2, I'll get the coordinates of A prime. So A prime will be at 4, 2. And I can repeat and do that for B and for C. So B is 2, 3, so B prime will be at 4, 6. C is at 5, 1, so C prime will be at 10, 2. So I go a little off the grid there. And here is my dilation. Pretty easy, don't you think? Yep. Except now we're working with fractions. So I still want to do the same thing. I want to multiply the coordinates by the scale factor. So like in number 4, I want to take like, I want to take like -6 and multiply it by 2/3. This is pretty easy to do. I just go directly across, so I could do it mentally. So I can go like 6 times -6 times 2 is -12, divided by 3 is -4. So you could probably do this in your head to figure out your new coordinates. So likewise, if I take 3 times 2/3, 3 times 2 is 6, and 6 divided by 3 is 2. So this is the new coordinates of P prime. I'm at -4, +2. And then I would just repeat for the other two, okay? So Q, like -3 would become -2, and 9 would become 6. So Q prime will be here, and then repeat with R. 3 times 2/3 is 2. 6 times 2/3 is 4. So that's how you can perform dilations on the coordinate plane. Simply multiply the original points of the preimage by the scale factor to get the corresponding points of the image. And that's how Becker breaks it down.